Predicting products is just the culmination of all of the stuff we've done in this unit, and it requires four steps. The first step is we need to predict the reaction type. So we're going to predict the reaction type here by identifying this reaction. And if I recognize this, I realize that my metal is going to replace my metal ion with my, in this case, polyatomic ion. So they're going to switch in what we know as a single displacement reaction. So once I can identify my types of reaction, I can now predict my products. So step one is do the type. Step two is going to be predict which products are going to form using my patterns, but don't write the formula right away because you'll probably make an error. Let's just write the name of what's forming. So this metal is going to replace that metal ion, and that metal ion is going to come out as the single atom in our single displacement. So I'm going to end up with Ag is silver, SO4 is sulfate. I'm going to end up with silver sulfate, and then copper ion is going to become copper metal, so it's just copper. So that's step two. Step three is we're going to write what the formula is. So the formula doesn't depend on what was on the reactant side. The formula depends on how it bonds. So if I look up silver, I find out silver is 1 plus ion, and sulfate is SO4 2 minus. If I do a crisscross, I get a 2 there and a 1 here. Now what that means, if I can clean this up for you, is I'm going to end up with Ag2 SO4 1, but of course we don't draw brackets or a 1. Copper is a metal, so it's just the symbol for copper. So now step 3, I've predicted my products. Now lastly, if I change my color here, go to black, I have to balance. So I have to balance my reactants and my products. I have silver, I have copper, and since sulfate is the same on both sides, I can balance sulfate. I have 1 silver, I have 1 copper, I have 1 sulfate, I have 2 silvers in silver sulfate, I have 1 sulfate, and I have 1 copper. Well, clearly this is not balanced. Since I don't have oxygen or hydrogen, I go any order I want. I'm going to go with silver. The way I can make 2 silvers on this side is a 2 as the coefficient, which makes this a 2, which makes this balanced. And that's all there is to it. Another example. So in this one here, it's weird because of Arial font with Arial font with that guy. I'm just going to put my red back on. That's an I, that's an iodine. So we have a triangle and a circle with a square, let's say, and a star. Well, hopefully you recognize that when I have an ionic compound and an ionic compound, I have 1, 2, 3, 4, I'm having a switch here. This is a double displacement reaction where these guys are going to switch places with each other. So that's a double displacement, step 1. Step 2 would be to predict the products here. So I'm going to end up, I had sodium iodide, I'm now going to end up with, not sodium, calcium in its place. So I'm going to have calcium iodide, and I'm going to have sodium chloride. Sodium chloride. Now the reason I write the names first is because if I just switch places, I'm going to end up with NaCl2 and CaI. Now watch what happens. Because I wrote the name, I'm going to actually figure out what the formulas are instead of just switching. So I'm going to say calcium, which has a 2 plus charge, and iodine, which has a 1 minus charge. Crisscrossing that means there's a 1 here and a 2 there. So I get Ca1I2, which is CaI2. CaI2, not CAI. So they switch spots, but they still have to bond properly. I still need to have full octets. I still need to have balanced charges. Sodium chloride is Na1 plus and Cl1 minus, which means that's just 1 and 1. NaCl, not NaCl2. So if you just go and switch them over, you're going to get them wrong, and then you can't balance it properly because they're wrong. So always say the name or write the name and then actually bond them the way we've learned, or else you're going to end up with wrong answers. Now I'm going to actually go ahead here and finish. We'll balance, which is the last step. So I have my reactant side and my product side. I've got a sodium, I have an iodine, I have a calcium, and I have chlorine. I have 1 sodium and 1 iodine, 1 calcium and 2 chlorine. On my product side, I have 1 calcium and 2 iodine. I have 1 sodium and 1 chlorine. Now it's not balanced, but I don't have any hydrogen or oxygen or polyatomic, so I go in any order I want. So I'll just go this way. Sodium's balanced, iodine's not. In order to get 2 over here, I need 2 of those. So that will change this to a 2. But it also means that I add a sodium, so that's 2. So 2 sodiums went in, only 1 came out. So I got to fix that by putting a 2 here. So 2 sodiums come out, but that also means there's 2 chlorine and 2, and I go 2, 2, 2, 2, 1, 1, 2, 2. That's balanced. So 2 sodium iodide react with 1 calcium chloride to produce 1 calcium iodide and 2 sodium chloride.